Okay, hi. We're going to do some of these problems. So the first example is, how much does a 25 kilogram dog weigh on Earth? So remember, when we're looking at these problems, we're looking for that information. And a lot of times we see numbers with units. So right now I see 25 kilogram. So I'm trying to figure out, what is that? Well, I use the units as a trick. And I say, all right, let me find in my table of friends my kilograms. And so I see that my kilogram means it's a mass and the variable is m. So I can just write m equals 25 kilograms. And so I can write up here m equals 25 kilograms. Okay, there's also, switch colors. There's also, it says, how much does it weigh? Right? So how much does it weigh is asking me for the weight. So I know that I'm going to be looking for Fg, and it's going to be a certain number of newtons. So I know that newtons is going to go right there for my answer, because that's what I'm looking for. And I can write F sub g equals question mark. Okay, so just sort of looking ahead, if we're trying to figure out, like, what's our equation that we're heading towards? We have Fg equals m times g. So I'm just going to write that up here and see where we are. All right, I have m, but I am looking at this question and it does not tell me what the value of g is, but it does have some other information, and it's telling me that it's on Earth. So I know that the surface gravity, right, the gravitational field strength of Earth is that. So I can write G Earth is 9.8 newtons per kilogram. Now I am ready, because I have all the things I need. So let's switch back to black here. Fg equals, here's my m, here's my g. My m, I look over at my knowns and unknowns. I see my m is 25 kilograms. That's a 5. And my g is 9.8 newtons per kilogram. So my number is 25 times 9.8. And I just put that in my calculator and I get 245. And look at that. I was so proactive in writing my unit. That's a really good little trick that I just showed you. I'm just going to do that from now on. I know that if I do this unit math, right, if I actually have kilograms times Newton per kilogram, remember from, just multiplying fractions, kilogram times Newton divided by kilogram, right, those kilograms cancel and you get newtons. And if that unit math is just too scary, you can just always look at your table of friends and see that there's your Newton. All right, let's do the next one. All right, ooh, we have a 25 kilogram dog again, but this time he's on the moon. So if he's on the moon, I know that means I'm going to use that guy. Okay, so let's do this again. 25 kilograms. I look at my table of friends. There's my kilograms. So I can just make this m equals 25 kilograms. Asking again about the weight. So Fg is question mark. And when I look down here at Fg, I can see I'm going to have my answer is going to be in newtons. So there it is. And my G here is going to be on the moon. So 1.6 newtons per kilogram. We're looking for Fg. So we get m times g. So F sub g is m times g. And let's plug things in now. My m is 25 kilograms. My g on the moon is 1.6 newtons per kilogram. And so what does my little doggy weigh? And I put put in my calculator 25 times 1.6 and I get 40. And I know that my units are Newton because I put those there already. All right. There's also this other question here. What is the dog's mass on the moon? And this ends up being a little bit of a trick question. We know that mass, right, is the amount of stuff that the dog's made of. And if he's on Earth or if he's on the moon, doesn't matter. It's the same amount of stuff. So 25 kilograms is his mass on the Earth and the moon. All right. You could have asked this question, what's the dog's mass on the moon, or what's the dog's mass on the Earth? Doesn't matter. Okay. Next one. All right, now we've got a watermelon. Groovy. It says a watermelon weighs 120 newtons on Earth. What is its mass? Okay. Weighs 110 newtons. So there's Fg is 110 newtons. On Earth means that guy, that my surface gravity is 9.8 newtons per kilogram. And what is its mass? So mass equals question mark kilogram. Let's throw our kilograms in here. And mass is question mark. Fantastic. Now we need a formula. Formula, we can look over at our triangle. I want mass. And so it's going to be mass is F sub g divided by g. M equals 110 newtons is our weight. And our g, we are on Earth, so it's 9.8 newtons per kilogram. And when you put 110 divided by 9.8 in your calculator, you get 11.2244898. But just round to, one or two decimal points and you'll be good. So 11.2 kilograms. All right. Let's do the last one. Ooh, we just went to Pluto. If the gravitational field strength on Pluto is 0.62 newtons per kilogram, that says the gravitational field strength on Pluto. So that's G of Pluto. What is the mass of an object? So mass equals question mark, and let's just make sure mass. All right, it's going to be kilograms as our final unit. And it tells you that it weighs 50 newtons on Pluto. So we need M. And we get that. So M equals F sub G over G. So M is, so we have a weight of 50 newtons. And my gosh, Pluto has a very small surface gravity. 0.62 compared to our Earth's 9.8. Pretty cool. So this is an 80 kilogram object and it only weighs 50 newtons on Pluto, right? That would weigh almost 800 newtons on Earth. Okay, I hope this helped going through the questions. Email me if you have any questions.